Welcome friends. Let us conclude our discussion on polar plots via a very interesting example of loop transfer function, which is 10 into s plus 1 divided by s plus 10. So today we shall learn how to draw the polar plot for this transfer function. So the textbooks we refer for control system are numerous, but this is one very simple textbook on control systems written by Professor M. Gopal. Two more reference books I would like to suggest. One is on control systems by Shom series, which has been rewritten by Indian author Professor Sanjay Mondal, and another very simple book on automatic control systems. This can also be referred by Professor Syed Hassan Saeed of Integral University, Lucknow. So let us start our lecture on drawing the polar plot for 10 into s plus 1 by s plus 10. So as usual, we shall assign s equal to j omega, and in that case definitely we will have g of j omega, h of j omega equal to 10 into j omega plus 1 divided by j omega plus 10. So you will see that there are interesting situations where we will play with 10 and omega. So there will be different powers of 10 and omega. We have to write and utilize it very carefully. So first let us multiply the numerator and denominator by the complex conjugate of the denominator. So I write g at j omega, h at j omega equal to 10 into j omega plus 1 divided by j omega plus 10. So numerator and denominator are multiplied by the complex conjugate, so minus j omega plus 10 divided by minus j omega plus 10. So if I go further, this should be equal to 10 multiplied by, multiply the product, so there will be two real terms, two imaginary terms. So how it will be simplified? So the real term will be 10 plus omega square, as you can see very clearly, plus j 9 omega divided by 10 square plus omega square. So we can say that this g at j omega, h at j omega, this is equal to 10 divided by 10 square plus omega square. So the other part is the complex number, so we can take magnitude of that. So what is the magnitude of that? This is equal to square root of 10 plus omega square whole square of this plus 9 omega the whole square of this. Then comes the face part, that is definitely tan inverse of imaginary by the real is 9 omega divided by 10 plus omega square. So this is limit of omega tends to 0. We start from the omega equal to 0. So this is g at j omega, h at j omega equal to, you see when omega equal to 0, so we have in the numerator the first term 10, then another 10 will come from inside the radical, so it will become 10 square. So divided by denominator is again 10 square, then the angle will become 0 degree because omega equal to 0. So this is simply 1 angle 0 degree. Now if we go for the infinite frequency, omega tends to infinity, then g at j omega, h at j omega equals to limit omega tends to infinity 10 by omega square. You see here, as omega is very high, so this 10 square is negligible, so this 10 by omega square into omega square. Then what is the angle? Here you can say the denominator will be in such that this is 9 omega by 10 plus omega square, so this is basically in the form of 9 by omega. So again, because omega tends to infinity, so this angle becomes 0, so this is simply 0. So we can write it in a simple way, that 10 angle 0 degree. So now is the point where we should say that this value of g at j omega, h at j omega for omega equal to 0 and omega tends to infinity will make us understand that there is a physical interpretation of the situation. What is the physical interpretation? Let us discuss the physical interpretation of the situation. Physical interpretation. So what is the physical interpretation? You should be careful to understand that for omega less than infinity greater than 0, real part of g at j omega, h at j omega, so g at j omega, h at j omega, and imaginary part of g at j omega, h at j omega are both positive, as you can see from the expression above. See from the expression over here, you can say that you have the expression over here. This is the expression. So from here we can say that the real and imaginary parts both are positive here, so it should be in the first quadrant. So let us see further how we can include this information. If I take now the real part of I write in short gh equal to 0, implies that so omega square plus 10 is the real part. So if this is equal to 0, that means omega equals to plus minus j root 10. So but our omega varies from 0 to infinity, which is a real number, so this is not possible. So we have to be careful that there is no such frequency for which real part is 0. Again, if I take imaginary part of gh is equal to 0, this implies that omega equal to 0 simply. So this has already been considered above, because at omega equal to 0 we have the magnitude and phase as 1 angle 0. So we are starting at 1 angle 0 where omega equal to 0. So now I have to understand that what should be the shape of the polar plot, because we are starting at omega equal to 0 where magnitude is 1, but imaginary part is 0, it means it is the on the positive real axis. Again, when omega tends to 0, omega tends to infinity, then the imaginary part is 0 and the magnitude is 10, again on the positive real axis. So it should be something like this. Just trying for your understanding. This is the starting point, this is the closing point, this is 110. So in this region we have something. So let us assume that there are some values of x and y. So for that, assume that x equal to 10 into 10 plus omega square into k, and y equals to 10 into 9 omega square, 9 omega into k. According to the real and imaginary part of the expression, I have assumed this condition. So if I take that, then square root of x square plus y square should be the magnitude. And what was the magnitude we had taken? The magnitude is 10 by 10 square plus omega square. We have to check it in the expression itself, then it will be clear. So you check the expression from here, from this part you have to make it clear, this part and this part. So square of this is the magnitude square. So let us see how it happens. Square of this part is magnitude square, means this into square root of this into square root of 10 plus omega square whole square plus 9 omega whole square. This way it will come. So when I am saying that I am squaring the magnitude, so this should be equal to 10 square definitely divided by 10 square plus omega square whole square into, now the radical sign will go, so 10 plus omega square whole square plus 9 omega whole square, bracket close. Now you incorporate the values of x and y. So if I incorporate the values of x and y, how it should come? It should come like this. 10 square for x square, you are getting 10 square plus 10 plus omega square whole square k square, and for y it is 9 square into 10 square into omega square k square, right? So this should be equal to, on the right what we have taken, 10 square into 10 plus omega square whole square plus 9 omega whole square divided by 10 square plus omega square whole square. So on the basis of this we just need to simplify it. So how we can simplify? If I solve it, it will become your 10 square, this is 10 square, then you take k square common, then in bracket what will come? 10 plus omega square whole square plus 9 omega whole square on the left hand side, and on the right side we have 10 square, 10 plus omega square whole square plus 9 omega whole square, bracket close, divided by 10 square plus omega square. So we can see that very easily these two brackets are cancelled, this 10 square is cancelled with this 10 square, so we get k square equal to this one, so k equal to 1 divided by 10 square plus omega square. So you can understand that if we replace the value of k in x and y, what should come? So we are writing x, value of x equal to 10 into 10 plus omega square divided by 10 square plus omega square, and y will come as y equals to 9 omega divided by 10 square plus omega square. This is because we had taken x equal to 10 into 10 plus omega square into k, and y equals to 10 into 9 into omega into k. So the value of k is replaced over here. Now we understand that the midpoint of the starting and terminating point, that is omega equal to 0 and omega equal to infinity, the midpoint is obtained as starting point is 1, closing point is 10, divided by 2 is 11 by 2. This is 5.5. So this is the midpoint. So if I want to check the value of omega at the midpoint, how I can do it? We simply assign 11 by 2 equals to the value of x is 10 plus omega square divided by 10 square plus omega square. If I solve it, it should come as 11 into 10 square plus omega square equal to 20 into 10 plus omega square. You open the bracket, so 1100 plus 11 omega square equal to 200 plus 20 omega square. So eventually we are here with 900 equals to 9 omega square. So this means omega 1 to 2 values of omega are equal to plus minus 10. So naturally we will take omega 1 equals to 10. So here we take omega 1 equals to 10. So which means that x equal to 10 into 10 plus 100, that is omega square, divided by 10 square plus omega square, means 100 plus 100 is 200. So this will again come as 1100 by 200 equals to 11 by 2. So at omega equals to 10, we are getting the midpoint. So what is the value of y at that point? Very interesting. At this time you replace y with the value of omega is 10 square plus 10 square equal to 900 by 200 equals to 9 by 2 equals to 4.5. So now the picture is little clear. See, you have the starting point 1, closing point 10, in between the distance is 9. It means the midpoint is 9 by 2, 9 by 2, 9 by 2, right? So again at the midpoint the value of y is again 9 by 2 from here. It means this is semicircle, right? So from here we can conclude that if we take the equation of a circle, in the way x minus 11 by 2, that is the x minus real part of the center plus y minus imaginary part of the center square. This is equal to, you place the values, 10 into 10 plus omega square divided by 10 square plus omega square minus 11 by 2, the whole square of this, plus 90 omega divided by 10 square plus omega square whole square. If you simplify this, we'll get 1 step, 2 step, 3 step, then 4 step. You have to do it very patiently because I have to save some time, so I'm skipping it. 5 steps. 6th step will come like this, 9 by 2 square into 100 plus omega square whole square divided by 10 square plus omega square whole square. So here these two terms are cancelled, equal to 9 by 2 whole square. So it means this is the radius of a circle. The value of the radius is 9 by 2. So now we are in a condition to draw the polar plot. So we have a polar plot which is in the shape of a semicircle, and this semicircle will have a center at 9 by 2 comma 0, and the center should be at 11 by 2 comma 0. So this should be 11 by 2 comma 0 and radius 9 by 2. So this one you can draw the polar plot of this in this way. Draw the polar plot. You have to draw the polar plot and write very clearly this is the real part of g at j omega, h at j omega, and this is the imaginary part of g at j omega, h at j omega. You have to write it very clearly. So here you have the starting point 1, where you have the closing point 10, and your polar plot moves like this, and at the midpoint omega equals to 10. Here omega tends to infinity, here omega equals to 0, and your center is 5.5 means 11 by 2. This length is 11 by 2, and this length is 9 by 2. This length is 9 by 2. So this is the radius. So this is the polar plot of GS HS equal to 10 into S plus 1 divided by S plus 10. So see how simple the transfer function looks, but when you draw the polar plot of it, it goes a little more distance. So in this way you have to analyze a problem when you are getting it in your hand. If you find this lecture useful for you, you like it in the YouTube, subscribe the channel and set the bell icon, and you can always write me the queries to my email ID controlsystemsfaq@gmail.com. Thank you for your patient listening.